I wanted to first walk through ChemSpider before we used it to look at possibly identifying unknowns in some of our samples. So let's first, what you need to first do is just type in ChemSpider. It'll bring up this interface, and you need to go to the Advanced menu here, where this allows you to search multiple things. The first thing you can do here if you want is you can draw a structure. You can go to their structure drawing program, and a lot of times when you draw something and come back in, it might be out of place. So always remember to come up here and go to Clean. That'll straighten things out for you. And the same thing for drawing structures. If you wanted to draw something, let's say I'll just draw another structure in here. Let's first just get rid of the one we had. So I use the little eraser button there. And let's draw something. Draw that. I'm putting a nitrogen on. It's not the greatest drawing program, but it's okay. So I'll draw carbon there. I'm going to put a 6-membered ring there. And let's just draw something a little crooked so it looks bad. And always remember, just go up and say clean. It'll straighten it out. So that's pretty much the structure drawing part of it, and it's pretty obvious how it works. It's a very simple program. The other thing you can do if you want to is you can load a structure. So you can go find a structure on your drive that you've saved in your drawing program. I've saved this one called, I think, structure test.mol. And save it as a mol file because that's one of the file formats that ChemSpider can import. Just say open. Now you can see I have my structure here. Again, when it comes in, it might be good just to clean it, just to say that. So if you don't want to use their program, just save your structures as mol files and bring them in that way. So that's pretty much that part of the program. You can do exact structure searches, just choosing all tautomers. If you want to do substructure, you click on that. Sometimes it takes about 5 seconds for that to change there from substructure from exact, or you can do a Tanimoto search and you pick how well you want it to match your structure versus the one you've drawn versus the ones in their database. But 90% is a good place to start when you're doing that. The other thing is that I use all the time is intrinsic properties. And here you can put in the molecular formula is one of the best things to put in because it's just very well defined. But sometimes when you get things over a certain molecular weight, it's hard to get one molecular formula. In this case, you can put the molecular weight here if you want to. And the best one, let's see, that's nominal mass, average mass. The one they want to use is monoisotopic mass. That's the accurate mass, and you always have to put in an error associated with that one. So that's one that's good to use. This average mass, that's the chemist's molar mass. That's not very useful. Nominal mass is not bad. If you know the nominal mass of something, nominal mass is defined as nominal. So if you had something that weighs 298, you just put in 298 and you put plus or minus 0 because that's defined by the most predominant isotopes, somewhat the way that NIST would have it in their program. All their spectra are entered by nominal molecular weight. So that's a good thing. But molecular formula or monoisotopic mass with an error window associated with it. And I think you can even tell it what kind of ion it is. You can tell it that the ion that you see is the molecular ion, or you don't have to correct if you know it's an ammonia addict if you're doing CI or LCMS or negative ion, so you can define it there. But whatever you have clicked and you have a value is what it'll search. So you only want to have, when you're searching one with a value there, you want to make sure it's not clicked. So if that was what we were searching, we would search there. So those are pretty much the variables that you would like to put in to search the program. I was looking for a little bit further down. The search hit limit, you can have 100, 1,000, 10,000. So if you come back and it says it searched and found 103 things, and you've got a hit limit of 100, it'll only show you 100 of the 103. So always make sure that number is large enough to see what you need to see from the search results. So be sure to do that. The other thing is when you first come into the program, if you have something clicked and you forget about it, like it's going to search structure here, unless if I unclick this little arrow here, if that's clicked, it'll search that. And if I have the intrinsic mass, so I'm doing an accurate mass, it will search it also. So it'll search both things here because there's two things selected by this little arrow, this little check mark here. So if you don't get any results, you get nonsensical results, you need to make sure that you have those set to either search or not search. So if you come down here, the other thing is when you come in sometimes, it's better just to say clear form. And that really just takes it back to the initial one. So it now it took a few seconds to do that, but now you'll see your structure is gone. If you come down to your intrinsic properties where you put in these things, they should all be cleared now, but that didn't happen instantaneously. Sometimes this program takes a little longer than one would like, so be sure to be patient with it at times. So that's pretty much the basics of it and using the program to make sure you can use it properly. The other thing is sometimes the screen flashes or you're on another window and you don't get, usually you're going to see the results at the bottom down here. So you have to scroll down to see what it's done. But sometimes you might miss that. And if you want to see what you missed, you go up here to history and it'll have a list of all your searches. So you'll see the last one that was done that you missed and you can just click on it and then the results will pop back into the memory. This is one that I had saved. You just scroll down and you can see that this is where I did a nominal molecular weight 295 plus or minus 0 and no mass defect. So I pretty much just searched and it found 755,402 things. Of course, it only showed me 100 because I had picked 100. I could go to 10,000, but when the numbers get this large, it's really nothing worthwhile to look at. You need to narrow your search. So those are pretty much the basics of using ChemSpider. So I'll say once again, make sure that you clear things. Make sure when you bring your structures in, you clean them at the top here. When you do structures, make sure you clean things after you draw them. You can see this one's gotten messed up here. If I clean it, it'll straighten up the structure. It's clean again. So you need to make sure that you make sure the number of hits are right. As far as at the bottom here again, I'm showing the first 100. So you need to make sure, be aware of all those parameters, and most of all, be patient. Sometimes the program takes a while to do things, and so you think it hadn't done anything, but it's just taken a while. Our first example we'll try using with ChemSpider was this compound that was a PCP-related thing in our talk earlier. And let's try a molecular formula search for the unknown to see how many are in the database for that species. So we'll come down and say clear form to get the form in a state that we know everything's cleared. We'll come up here to intrinsic properties and open it. That's where our formula should be, C21, H29, N. I'm going to close it and open it again, make sure it took the value. And you have to make sure the check's there before it'll do the search. So I'm just making sure the value's in and I do see the check there. And then I come down and say search to get the new search results. You see it says it's searching, which is a good sign. And then if we scroll down, we'll see that we found 4,239 results. A lot of times for more common compounds, not these particular drugs that we might be interested in, if you sort by the number of data sources or the number of references or any of these columns, it might bring the one that's most likely to be the hit at the top. But if you can look here, there were so many, 4,239, and also we only specified 100 results in the hits, but really that's just too many to get a possible hit, so we need to narrow the search in some manner. So let's try to narrow the search a little bit by putting a structure in, or a substructure. So we'll put our aromatic ring for a compound, put the central carbon that was in the substructure that we got from the hybrid data for this compound. We'll put in the cyclohexyl ring, and then put in the nitrogen. And then we'll just clean this up, straighten it up a little bit. And now we just need to make sure the check is on there, so it'll search by structure, but we want to do a substructure, not exact structure. Sometimes it takes a few seconds to do that, but now it's showing substructure. We need to go down to our intrinsic properties just to make sure that the molecular formula is still defined. So we'll put that in, C21H29N. I'll click in this other box, go up here, and I'm just going to toggle back and forth one time just to make sure it's got it selected. So that's good. We still have our molecular structure, the substructure, drawn. So we ought to be able to do a search now and limit it by those two. So do a search. Should say searching. That looks good. The searching icon or the box came on in the middle. Wait for that to get through. Sometimes it might take 45 seconds to a minute to do this, so if it takes too long I might cut it out and come back at a later, so you don't have to sit here and watch the search occurring. But I'll wait for a few more seconds and see what happens before I stop it, at least so what you see, and then wait till it comes back with the results to jump back in again. Now the results have come back, and you can see we only found one result that was consistent with it, and it was the structure for the compound. So we got that directly without having to do any of the complicated chemistry, figuring out which ketones might have reacted to do it. So that worked fairly well. So let's just pretend we don't have the molecular formula here, and all we know is the nominal molecular weight. Well, let's clear our form first. Well, we'll turn our structure off up here for now. So I'm going up to where the structure was. I'll leave it in there, but I want to turn it off so it's not searching by structure. I want to come down to the intrinsic properties and now put in the nominal molecular weight, which is 295. You got to remember that the nominal molecular weight has no dimension, so the error is 0, because in the NIST program things are entered into the program when you import them by the most predominant isotope. Carbon's 12, hydrogen's 1, nitrogen 14, oxygen 16. They're all nominal masses. When they add up, it should be nominal mass. The only problems you'll have if you get compounds with too many hydrogens or too many bromines, it'll make this nominal mass not be correct in the NIST program, and you'll need to correct that. And it talks about that in some of my software for the NIST search. But in general, the nominal mass is what you observe in the NIST library when you're doing the searches. So in this case, it was 295. I'm just going to toggle this on and off. Sometimes it doesn't get the values that I want in there, so that kind of refreshes the screen. It held, so it's 295. Need to go make sure that the structure is not selected, and now we'll do our search to see how many compounds have a nominal molecular weight of 295. Again, it's doing the search, so that's a good sign. Everything's working and set up properly, and there'll be a lot more here than there will be for the molecular formula, because there'll be a lot of things that don't have the same molecular formula that have a molecular weight of 295. This might take a lot longer to search, so I might stop the view that you see in the video and come back in when it's complete. All right, the results have come back, and this took probably close to a minute to do. And you can see instead of our 4,000 that we had by the molecular formula, we have 750,402. Definitely you can't look through this list, and it's showing you the first 100. Even if you said the first 10,000, that's just too many results to even consider looking at. You can see a lot of things have different molecular formulas, but the same nominal molecular weight. So again, we need to refine our search. So we'll go up to the top and we'll turn on this substructure again. And I'm just going to close. I'm just making sure everything's set up right. The nitrogen's still where it looks like it should be. I've got it checked, so it'll search by structure. And I want to just make sure this is right. So I'm going to turn the intrinsic properties on and off just to toggle the display and make sure it's still set at 295. And again, the results that I gave you a minute ago, that took probably close to a minute. So all these software searches, these database searches, in some case, depending on what they are, can take up to a minute to do. So be patient and let it give it the program time to look at the result, to give you the results. So I think I've got everything set up right. So I'll start the search again. And again, we got the searching going, so that indicates everything's working right, and I've got all the values entered right. And again, this might take a very long time. It's got 755,000 things to sort through by substructure to give you the results, and so it might take a minute again. So again, I will quit talking for right now, wait for the display to come back, and then cut that time out so you don't have to wait, and then show you the results. So the results have come back now. At the bottom of the page, now we have 50 results that came out of that 755,000 total results. But now instead of having the very few noted when we did the molecular formula, we have 50 results to go through. You could sort by the number of references or the number of PubMed, or the number of data sources, but you have to be careful for these types of compounds because the number of associated data points for these might be very low. So you're really kind of forced to look through them and find things that make sense. They all have the right molecular formula, but we're looking something that has this part of the structure with something hanging off the middle, but no branching over to the side off that ring. So you're really kind of forced to look through the 50 results. So we'll scan through them simply. I've already found the one that looks most likely. The other ones just don't meet the criteria of the hybrid search. We'll go to page 2. Again, looking through some of these. Again, nothing that really fits our substructure that we are expecting. And I'll do the third page of them. And again, nothing meets the eye as being useful. So on our first page, we did have the result we're looking for, but you can see this is a little bit more work and a little bit more to look through. But if you didn't have the availability of accurate mass, it is doable with the data to visually find the correct structure here. I thought it'd be interesting to also try a Tanimoto search here. So if you come down, we've got our structure in. I'll just do a clean to make sure it's okay. Everything looks good there. And I'll go down to Tanimoto this time. Before we were doing substructure. It always takes about 5 or 6 seconds after you touch these to get them to work. Go to similarity. The similarity is a Tanimoto. It looks at what's like something. And so you really have to decide what to set this at. I'm just going to go ahead and set it at the lowest value now, just to open it up wide to see how many structures I get so I don't limit anything. So I put it at 50%, and we'll go down to our intrinsic properties. Again, click on it once, click on it again. We've got our C21H29 in. It's just good to toggle this sometimes because sometimes it doesn't take the value. Nothing else is there. So now we have this is checked. This is checked. Those are the only thing that have any field information entered. And we should be able to do our search now. So go to the bottom, do a search. It's good. The searching menus thing is going around and around. That indicates I've got everything right. But again, this might take up to a minute or so. So you have to be patient and wait for it to stop. So I might stop the display that you see and wait till it comes back in to show you the results, just so you don't have to sit here and look at the screen while we do this. All right, the results have come back, and you can see now we only found 6 with the Tanimoto filter opened up to 50. If we'd have driven it up toward 80 or 90, we probably wouldn't have found all the results we need. And this is a reasonable number to look at, so it's better to be cautious and err on the side of getting too many as opposed to cutting out something of interest. If you start looking through these, again, the substructure we're looking for is the 2 rings with something between them. And there's really only one there, and again, it's the compound that we wanted. So I've shown you several ways to do this. You could even do this with the nominal molecular weight. I'll go back and try that just for completeness and show it in the next time segment. I did the search on the substructure that we had above. So I did the same substructure. I did a Tanimoto with equal to 50% to make sure I caught everything. I entered in the molecular weight. So let's clear this field to make sure that's right. Let's click this, toggle it one time just to make sure it clears it. And we've got the nominal mass of 295 plus or minus 0. Since it's nominal mass, you don't have any variation because there is no error associated with that. And let's just click the intrinsic properties once and twice just to make sure it cleared that field, got that field entered. So we have a check mark there. We have a check mark up here. Should be good to start the search now. Got everything set up to do the search. You can see it's doing the searching. And again, this might take a while to do, so I'll wait a few seconds here, but then I'll just exit the active display and bring you back in when the search results are shown. So the search results are done now. Instead of the very few number we had before, we have 90 here to look at over 5 pages. So that's going to take a while to look, but we got to make sure we didn't increase past the 100. And we did a structure search, similarity, and I'm just reading to make sure it did what I wanted to do. 295 to 295 with no mass defect. So that's all good. So you'd have to sit here and look through these. So I'll just scroll through them very quickly. I really don't see anything of interest there in the first page. All of them don't have something branching out of the center methylene group. So we'll go to page, that was actually sitting on page 1. Here's page 1. Might have been on the wrong page. I was on page 2 for some reason. So if we scroll through page 1, we won't see anything. And there was our compound. Page 1. Sorry. There it is. So it is still in this list. And don't see any other candidates. I'll go to page 2. And you have to wait for that to re-display. You see it's jumped to the new one. You'd have to look through all 5 pages. I did look through all 5 pages in another search. There's really nothing in it, but it's just going to take a lot of time. So you'd have to be a lot more patient to look at these results, though it's doable, but not as nice as having the molecular formula from the accurate mass data. But if you don't have that capability, you could approach the problem in this manner. I did one last search on this compound, on this other compound. And I drew it in here. I imported this structure by saying load structure, and I had it drawn as a mole file, and it brought it in automatically. And I decided I would do a Tanimoto search on here with an 80% match factor for the similarity. And I set the intrinsic properties. I made sure I toggled it to make sure that it took the molecular formula to keep the number low. So I used the accurate mass data, make sure there's no nominal mass in there. And I searched it. I'm not going to show you the search process, but I'll show you the results. If you bring it down, I had 21 results that met this molecular formula and a similarity of 80%. And you can see some of these would not fragment correctly. These would have a 91 ion for the phenyl CH2 or something related to that, so they don't make any sense. Here's the compound that we determined it was from the other data from the other laboratory. So that looks pretty good. This one might give somewhat of a similar fragmentation pattern, though it might tend to crack more in this ring. That might be a little hard to tell. Again, this one might be a little bit more difficult to determine. We have another one here where the phenyl is on the outside with the nitrogen in the ring in this case, and that would probably fragment very similar. But again, the hit numbers, the number of associated references or data sources has fallen off. So compared to these, you can always go with these to kind of get an idea of probability of the likelihood of your structure. So, but that would be hard to determine without other data. And some of the other ones fall into that same category. So if it hadn't matched the known compound of known structure, then we'd have to consider some of these other possibilities by either NMR or finding out if there's a reference spectra or other information to narrow it down to the exact structure. So I think in this case, the Tanimoto was useful just to make sure if there were other possibilities that we hadn't considered, we would have some other options of proposed structures. So that's pretty much the end of my ChemSpider demonstration. And the main thing I need to say is you got to make sure that the right values get entered, make sure they're checked properly. Sometimes you need to toggle that window open and close to make sure the values entered properly. See that the search button is going around that shows it's searching, and then look and make sure when you look at the results of what it did to see if that matched what you asked for. So thank you for your time. Good day.